Welcome to section 12.1, Areas of Rectangles Revisited. Here are the topics, skills, and understandings, and the standards, the grades, concepts, and vocabulary. So area is the measure of how much two-dimensional space a shape takes up, and we've already discussed this, but we're going to revisit this and examine progressively sophisticated thinking about areas of rectangles and attend more closely to the units of measurement involved. This section does have explorations. Please make sure you're doing these. Have fun. Explore the material. Don't move on until you've tried your best. There's not a right or wrong answer. You're just playing and uncovering the material. So go ahead and explore here and press play when you're ready to move on. So now let's understand the area of rectangles. So before they learn the formula, they have to learn what area means. So for example, what does it mean to say that an area of a shape is 12 square centimeters? Well, it means that the shape can be covered without gaps or overlaps with a total of 12 1 centimeter by 1 centimeter squares. Now, this allows for the squares to be cut apart and moved around if necessary. So if we're given a 4 centimeter by 3 centimeter rectangle, a primitive way for students to determine its area is to cover it snugly with 1 centimeter by 1 centimeter square tiles and then count how many tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And although it's really primitive, it's important. We don't want to skip this step with students because we want them to understand this method relies directly on the meaning of area and then emphasizes it. But now we can go a little further, right? So covering rectangles with square tiles, it's important, but it's slow. So there is a quicker, more advanced way, which is based on the multiplicative structure that rectangles exhibit when they're broken into squares. So these squares can be viewed as organized into equal rows or columns. So we're still doing that, but here we've got 4 rows with 3 squares. Row 1, row 2, row 3, and row 4. And because there are equal groups, we can multiply. So here we can multiply 4 times 3 because we've got groups of 3. We've got 4 groups of 3 squares. Now we can go a little bit further and take that method and apply it to a general formula and see that, okay, in this case it was 4 times 3, but that would work for L times W. For every L and W, we can apply that same thinking, which then leads us to our area formula, which is length times width. So when we explain why we can multiply to find the area of a rectangle, we make equal groups of squares. And we find that we can make L groups of squares and that there are W squares in each group. Remember, L groups, so L groups, this many groups, right? That each have W amount of squares. Let's do an example. So you have a 5-foot by 7-foot rectangular rug in your classroom. You also have a bunch of square foot tiles and some tape measures. What is the most primitive way to determine the area of a rug? So that would be to cover the entire rug with those square foot tiles and then count them and see how many you've got. Now, what is a less primitive way to determine the area of the rug? So what we could do is we could take those square tiles and we could just cover the length. So we've got a 5-foot by 7-foot. So we would have 1, 2, 3, 4, 5 square foot tiles going in this direction. And then we could go this way. We would have 1, 2, 3, 4, 5, 6, 7 going this way. And we could say that we're going to have 5 rows, 1, 2, 3, 4, 5 rows of 7 square tiles. So then we could multiply 5 by 7. And here's a written out way to think about it. You go ahead and give these 3 problems a try. Press play when you're ready to see the solution. And there we go. Let's look at another example here. So a room that is 13 feet by 20 feet needs to be painted. The ceiling is 8 feet above the floor. There are 2 windows in the room. Each one is 3 feet by 4 feet, and the door is 2.5 by 7 feet. Okay, we got to draw a lot of pictures here. So we know that a room is, so I'm going to just draw a room for a minute. I know that we're talking about area, so we're not looking at this whole thing. But a room is 13 by 20 feet. And that the ceiling is 8 feet above. So we know that this wall here is 8 feet. And there are 2 windows in the room. So, you know, we're going to have some windows and we're going to have a door. Okay, so we're going to have like 2 windows. And I'm going to draw different photos here, but just so we can kind of see what's going on here. So this is 6.5 by 2, and then this is 3 by 4 and 3 by 4. All right, so find the area of the walls and ceiling to be painted. Well, I know that the ceiling is going to match the floor. So the ceiling is going to be 13 by 20. Rectangle. And then let's talk about walls for a moment. So this wall here is going to be 20 by 8. And there's 2 of those, right? There's one over here too. And we don't know where the windows are, but let's just say that the windows are on those walls. So then those windows are 3 by 4, and those windows are 3 by 4. And then we've got another 2 walls, right? We've got these 13 by 8 walls. And we've got to count for that one door. So that door is 6.5 by 2.5. So now we want the area of all of this. So we want the area of this, we want the area of this, but not including the windows, the area of this, but not including the windows, the area of that whole wall, and that wall. So let's look here. So this area is just going to be 13 by 20. So that's 260 square feet. Now this wall is going to be 8 by 20, but we're going to take away the window, 3 by 4. So that is going to give us 148 square feet. And this is going to be the same. Now this area is just going to be 8 by 13. There's no walls or windows there, so that's going to be 104 feet squared, or square feet. And then here we've got, okay, that's going to be 8 times 13, but we need to subtract that door, which is 6.5 times 2.5. And when we multiply that in our calculator, we get 87.75 square feet. So now let's just add all these up. 260 plus 148 plus 148 plus 104 plus 87.75. If you add that in your calculator, I think you should get 747.75 square feet. Now, if 1 gallon of paint covers 63.69 square feet, how many gallons are needed? Well, these are how much square feet I'm covering. So let's divide that number by the gallons, and let's see what we get. Type that into your calculator, you get 11.74. Well, they don't sell 7.74 of a gallon, so we need 12 gallons. Now, at $19.58 a gallon, what's the cost? Well, I'm going to just take that 12 and multiply it by 19.58, and we get, it's going to cost $234.96. Let's go ahead and give this problem a try. Actually, and then press play when you're ready to see the solutions. And there you go. And continue on exploring here and press play when you're ready to move forward. So now we're going to talk about fractional side lengths. So we know that no matter what, if it's a rectangle, length times width. So maybe you're saying, oh, I'll just multiply this by this. And you're absolutely correct. And it works no matter what kind of number, if it's a decimal, mixed number, or fraction, we can multiply those and get the answer. But let's make sense of it. So we can say that, okay, this rectangle is 3.5 centimeters by 2.5, and if we cover it with 1 centimeter by 1 centimeter squares and parts of 1 centimeter by 1 centimeter squares, then there will be 3.5 groups with 2.5 squares in each group. So here, this is 1, 2.5. So this is one group of 2.5. Here's our second group of 2.5. Here's our third group of 2.5. And here's a half group of 2.5. So we have 3.5 groups with 2.5 centimeter squares, or square centimeters. Of course, we can always count up the whole squares and collect the parts and also see that we've got, okay, 1, 2, 3, 4, 5, 6. That's 2 halves make 7. 2 halves make 8. Oops, here we go. Let's do this. 2 halves make 8. And then we've got a half and a quarter. So that's going to be 8 3/4. So of course we can also do it in that way. Let's look at this example here. So explain how to decompose the large rectangle into 2.5 groups with 3.5 squares. So this would be, if we're trying to do 2.5 groups of 3.5 squares. So here is one group of 1, 2, 3.5 squares, centimeters. And here is our second group of 3.5 square centimeters. And here is a half group of 3.5 square centimeters. And so that represents that right there. So now calculate it without a calculator, and let's see how that comes together. So that would be, so that's one group and two groups. So that's 7 centimeters squared. And then here we're going to get, oops, let's see here. We've got 1, 2, 3, 6, 7 centimeters squared. And then we've got a half group. So this is just half of this. So this is going to be 1.5, half of 3, and a quarter. So that's going to be 7 plus 1 is 8, and a half and 3, so that's going to be that. So let's see if without a calculator we get the same thing. First, let's turn these into improper fractions. 7 over 2. Then we'll multiply across. That's 35 over 4. And then that's going to be equal to, let's put it back in, so that would be 7. 8 times 4 is 32, with 3 left over. We get the same thing. Go ahead and give this a try. Press play when you're ready to see the solution. And that concludes 12.1. And we'll come back and finish this section in the next video.